Hey guys, so yeah, welcome back to the last and final part of this paper. I guess this paper, part 4. Yeah, sorry if you're hearing a lot of background noises. Can't really do anything about it. It's daytime, and I've literally closed all the windows and doors of my house to reduce the background noise. So, and I can also afford to do it at the night, which I usually do because my mock is literally in a few hours. So I need to practice. Okay. So first of all, I was actually trying to do it this before starting the video to save some time, but turns out this is not how we're supposed to do this. Um, so yeah, I actually wrote this formula like in the partial fractions, but I mean in the book there are actually 4 formulas given. So I got the mark scheme. I even used like asked Gemini and all that we are actually supposed to use the extended. An extension of the formula square, which in the mark scheme is given as sorry, not x square but yeah, x plus 2, something like this. Well, this is in the mark scheme, but in the the AI's app like Gemini writes x plus 2 under b and x square under c. So I guess both are okay, but as this is the given in the mark scheme, so let's just do this. I mean, yeah, what can we do right now? Let me just quickly remove this. Man, I wish we could do this type of thing like in the exam, like erasing it just like that and all. It would be much better to do like the options that we get digitally. Anyway, so let's just quickly correct the formula. So as I said, sometimes we don't know. We wouldn't know some formulas and some techniques or some facts unless we actually practice the question papers. I will also explain the thing that I was not able to explain yesterday. Not this vector question, yeah, this one. Like y cot pi by 2 is 0 and y 1 by 10 pi by 2 is undefined or like math error. Okay, so let's just quickly do it. There is nothing much to tell anyways. Wait, don't even need to write like this. Wait, is this correct? Let me just check. Oh, the thing is, I think like in the denominator we can actually do anything. Like I don't know, like we can also do this. I guess it really doesn't matter. Yeah, so let's just do this. What should we take the value of x now? Let's take it -2. X square. So a gets cancelled out, b gets cancelled out. There's only c. Cancel out. Yeah, like -2 plus 2 is 0, and if you multiply a with 0, a is gone, and same with b. So which c is actually 4c. C is 2. Sorry for my handwriting. Okay, so we have found the value of c. Now let's take a value, let's take 0. um let me just use dotted lines, or like you can, I mean it doesn't need to be dotted actually. I believe 0 square plus 0, so it will be 6. 0 plus 2 is 2. I mean a is also getting cancelled again, since a times 0 is 0. So 6 is equal to b. 0 plus 2 is 2b. So we know the value of c, so 2 times 0, actually if x is 0, then c is also getting cancelled. So b is 3. Yeah. Then we just need one more value. Let's take 1. Eight. Yeah, it will be 8. So 1 plus 2 is 3. 8 times 1 is 1, so 3a plus 3 times 3 plus 2 times 1 square is 2. We just write that. So 8 is equals to 3a plus 11 . Okay, so it will actually be this a is -1 by x plus b is 3x square plus 2x plus 2. So yeah, this was it. So the formula we need to remember, that's not given in the book, but yeah, I mean maybe you can, like, according to AI, this is an extension of the formula that I shown previously, like a by ax plus b by ax plus b whole square. So a by x plus b by x square plus c by x plus 2. Yeah, anyways, before doing this, let me just show why it's called pi by 2 0, but 10 pi by 2 is not. I mean 1 by 10 pi by 2 is like error. So basically, wait, yeah, sorry again for the background noises, can do nothing. So let me just use, I'm not do I sorry, yeah, so basically cos pi by 2, I mean sorry, not cos pi by 2, cot pi by 2 is equals to cos pi by 2 times sin pi by 2, which is 0 by 1, which is 0. Fine. But on the other hand, tan pi by 2, tan is sin by cos, right? Sin pi by 2, cos pi by 2, 1 by 0, undefined. So if you do 1 by tan pi by 2, which is 1 by undefined, this is error. Yeah, so I don't think this is a common knowledge actually. But anyways, so I guess I'm gonna leave it here. Wait, let me just write it properly. even though I usually do 1 by 10 for cot, not cos by sine. So yeah, that was a problem for me. So like it's better to use cos by sine instead of 1 by 10 in these cases. But on the other, if you see, tan is a sine by cos, right? So let's set 1 by tan x, right? So let's just cot x is equal to 1 by tan x, which is 1 by sin x by 1 by 1 by sin x by cos x is in fact cos x by sin x. So yeah, this is like a weird thing, but mathematical is correct maybe if you do graphs and all. So yeah, even though cot x is ultimately cos x by sin x, but I mean we're using tan x to actually come to this conclusion. So yeah, so if you do 1 by tan x is wrong, but if you do cos x by sin x is correct. Okay. Yeah, that was a weird thing actually. I didn't expect that. Okay, well now we need to integrate f of x. So and show it. So I don't know what's P3's obsession with integration. Like so many integration in a single paper. I've noticed it. I mean, almost every question has integration. Okay, so we need to integrate this actually with the limits of 1 and 4. So should we write it like this: minus f minus 1 plus 3x minus 2. Wait. Okay, so I just went to check something. Like the integration of negative 1 by x. Like in the marks we given as ln x, but it should be negative ln x. So let's just do in our way and let's see if it's correct. Like the marks thing sometimes makes mistakes, so let's see. So the thing is the integration of 1 by x is ln modulus of x. So we don't need to write the modulus here in this case, but it's better to write. So we can write as negative ln modulus of x plus 3x minus 2 if you do it. Like I'm just doing it in the side, no need to do it in the side. I mean, yeah. Like let's just write it as here. Like let's show it properly. 2 by x plus 2 is actually 2 ln x plus 2. Hopefully you guys know how it works. Like yeah, or let me just show it how it actually works. So take the 2 out, 1 by x plus 2. So if we differentiate this, we actually get 1. So we multiply the 1 here and then we divide it by here. So then we write it 2 ln, we leave the integration and write ln, and then we write x plus 2. Yes, so this is what's supposed to be actually ln modulus of x. Oh no, we are not actually done with the integration. Wait, yeah. Yeah. So now we integrate negative ln modulus of x plus 3x to the power minus 2 plus 1 is actually like 3x minus 2 plus 1 by minus 2 plus 1 is actually negative 3x to the power minus 1. So just write negative 3x plus 2 ln x plus 2 and we put in the limits. So negative ln 4 minus 3 by 4 plus 2 ln 4 plus 2 mm. Mm, it's correct, right? So we can write this as negative ln 4 negative 3 by 4 plus 2 ln 6 negative ln 1 so negative ln 4 minus 3 by 4 plus 2 ln 6 plus ln 1 wait ln 1 plus so negative ln 1 minus 3 is actually negative ln 1 minus 3 is actually negative 3. So wait, negative 3 plus 2 ln 3. So negative ln 4 minus 3 by 4 plus 2 ln 6 plus 3 negative 2 ln 3. It's a 2 ln 6. And negative ln 4 minus 3 by 4 plus 3. So it's 2 ln 6 by 3 which is 2 ln 2. Negative ln 4 minus 3 by 4 plus 3 negative ln 4 minus 3 by 4 plus 3. Okay, so I'm out of the page. Like maybe I should have done lesser steps, but yeah, let's just continue. I don't think the writing here is a good idea in the actual exam. So I guess I'm just showing too much steps. So 2 ln 2 minus ln 2 whole square. Not I guess not necessary. So yeah, negative ln 4 plus 2 ln 2 What is it going? Yeah, we can actually write it. On 4 is actually like log 2 square. So negative 2 ln 2 plus 2 ln 2. It actually gets cancelled out, I believe. Yeah. Minus 3 by 4 plus 3. So this cancel out. 9 negative 3 by 4 is 9 by 4 and shown. Oh, man, why are things so lengthy here? It's irritating. Did I complete this one? 9 2. Yeah, I did. So the last question. Okay. The complex number u is given by this. So I'm also working without using calculator. Find the square roots of u. Give answer form where the numbers n be the real and exact. I think we should do this, right? Whole square, which is a square plus 2abi plus bi whole square, which, yeah, bi whole square. I don't know what such it is. Wait. Yeah, so a square plus 2ab iota negative b square. Why? Like, you just input the value of iota square. Okay. There. Yeah, I know it's not aligned with the line. Anyways, so a square minus b square is negative 3. And 2ab is actually negative 2 root 10. But wait, so we can like do a substitution method, like ab is equals to negative 2 root 10 by 2, then a is equals to this, then we can substitute the value here. But yeah, that actually takes a lot of space and time. So what I'm gonna do is, nope. So this is a square plus b square negative 3 square plus 2 root 10 square. Basically I'm doing modulus. let's see if we can do it this way. So let's say this is equation 1, let's say this is equation 2. So a square, let's just do it naturally. Like, let's add the equation. I'm not writing at the addition, I'm just showing it. You know what, let's just write it. Yeah. So if we add it, 2a square, 7 minus 3 is 4. A square is, wait, what was the value of a? So it's plus minus root 2. So if we substitute in b, let's see. Yeah, actually there's not, it's not necessary to do this right now. So yeah, let's just write a square is 2. So then 2 plus b square is equals to 7. B square is equals to 5. So yeah, we have a square and we have b. We have a square and we have b square, right? Okay, so a is plus minus 2 and b is plus minus root 5, actually root 2. So a plus b iota, right? So a b is supposed to be negative 5 or what? Okay, so the thing is, since here AB is actually negative 10, so A and B must have opposite signs. So it's either root 2 minus root 5 iota, or minus iota root 5, if you want to give it in the exact form. Let's give it in the exact form. Yeah, iota root 5 and minus root 2 plus iota root 5. I think this way is acceptable, since like it's actually a shortcut. I mean, the thing is, I don't know about you guys, but if I did the substitution method, like let's say b is equals to negative root 2 by 10 and then a is equals to negative root 10 by b or whatever comes, and then if I put that in these equations, then I would actually eventually end up with an equation like this: a4 plus 3a square minus 10 is equals to 0. Then maybe I have to do another thing, like let c is equals to a square, then it will be c square plus 3c minus 10 is equals to 0. Then I need to solve this, then a square is equal to that value and that value. So it's actually a long process. Like in the mark scheme they've given this, but I think this way is also acceptable. Like this should also happen. But the thing is the space. Like you can use this additional space. I'm not really sure if this, like, I think this is acceptable. This is also a mathematically correct way. So yeah, I think this is acceptable. Okay, so this is an Argon diagram, and I'm actually still not good at Argon diagrams. So let me just do what I've understood by reading a mark scheme. So first of all, obviously we need to do a graph. I mean, not, yeah, like we need to draw the axis. At least fine, right? So the thing is, it is actually z minus 3 minus alpha. It was something like this. I don't remember what it was. Is less than. Sorry. And this background noises are killing me. One of the reasons I don't want to live in this country is these background noises. I mean, there are noises in other countries, but I'm pretty sure they're like monitored or something. Like I don't hear background noises in people of like US and all. Wait, so whatever is doing, so yeah, z minus 3 minus iota. It was something like this. I don't remember what it was. So yeah, so the coordinates is actually with 3 plus iota. So yeah, it's less than equals to 3. So yeah, it won't be a dotted circle. So we need a 3 and 1. Okay, okay. So this is actually the real axis, and this is the imaginary axis. So let's do a 3 1. Let's say 3 is here, and let's say 1 is here. Does it work? I mean, I don't know. I'm just randomly putting it, but we should be as accurate as possible. So I don't mind using a scale. Let me do it centimeter wise. So here is 3. So here is 1. So there will be a point about here. This will actually be the center for some reason, and the radius is 3. So we just draw a circle with radius 3 centimeter. What am I doing? I don't know what this radius is. Yeah, it's definitely more than 3 centimeter, I believe. So the center should be this, right? Wait a minute. Yeah, so it was somewhere there, like the diameter. Yeah, nice about fine. So yeah, I think this is the finest I can go. So we need to draw a line. I'm not measuring anything. Yeah, this is not the line that I'm supposed to use to do. Yeah. So this is a half line actually, and this is supposed to be pi by 4. I have to measure is greater than equal to pi by 4, and for this we just need to draw a line at 2. So I'm just guessing where 2 would be. So let's say here. Man, the lines. Wait. Yeah. So this is imaginary line is equals to 2. And what did this? So which region should we share? So for the circle, it should be for, it should be inside the circle. Okay. Like I don't know which area should I shade, or like it should be less than pi/4, like here, this region, or greater than or equals to 2. So this region, I'm not sure. Like I don't know why, but yeah, the mark scheme says shade this. I would have shaded this actually. I mean, yeah. So sorry that I still don't understand this well yet. Like if I figure out in the future like how to do this, like I will explain it in the comment section, or like I will upload a short video just explaining this part, and I will just give the link in the description. Okay, so this was pretty much it. Actually I need to do another paper right now, so yeah, see you guys, bye.